All right, so the recording started, hopefully. Yep, it did start. And this is the problem I did in last class. So our goal today is very simple. We'll try to solve this one and this one. Okay, two problems we had. What that we are doing here, let me quickly show you the theory. So this is impulse and momentum. Okay, you see principle of impulse and momentum. This is the theory slides that I would like to give you a quick overview of what you have learned. I believe you did learn it on last week Friday. Okay, on Monday you had the exam review. Okay, so exam 3 review. So here the idea is very simple. Impact means force multiplied time, and the momentum means mass multiplied velocity. You remember that, right? So change of momentum is equal to impact. That's what we know, right? So change of momentum means what? To understand it, say like okay, all right. So two things moving, different velocities, right? Impact happen, right? So the momentum changes at the same time, right? The velocities that change when the impact happen. So impact would be like okay, force it that impact with a certain amount of time, then the impact is happening now. That time would be much less than 1 second. It's a very small amount of time. You understand that, right? So that value, force multiplied time, whatever that time. Not necessarily it would be small value. In this case, it is like that, right? It could be even higher value. We're doing problem today, higher values, right? 2 seconds, 4 seconds, 6 seconds. But in this case, it is smaller than 1 second or whatever. So this force multiplied time should be equal to this change of momentum. Momentum again is what? Mass multiplied velocities, right? Understand that? So this train problem, right, Joe? We'll be doing it in next week. Okay, this train problem, like one train is going, another train is coming and hitting on the back. One train is coming this way, another train is coming in the same line, same track, collide. So what will happen, right? So again, change of momentum and the impact relationship, that is called principle of momentum and impact. That's what we'll be using. That's what we had used before, like the ball problem in last class, and that's what we'll be using. That same thing we'll be using today in improvement problems that we have. Any question? Okay, that's the theory. Okay. Now let me move on. All right. So let me get my class number by the way. And we have these two different problems. Uh, let's deal with this one first, I guess. Yep, let's deal with this one first. So this one we did already. Yep, this one, number 2. Okay. All right, let's try to read through this problem. I believe I did upload all the materials, like these materials in Brightspace as well. Anyone check this Brightspace materials? I mean, no, time to time you didn't check. Anyone else checked? Alisa, you checked the Brightspace material? Do I have chapter 15 already? Chapter up to chapter 14 for sure I have. Like this chapter 15, I gotta check myself also. But this material, the reason I'm saying all of this because this material should be over there so you can avoid the writing. So that's the whole purpose of that, right? Used to be like you have the access of OneNote. Now they don't allow you to have access of OneNote. Okay, so I have to go that different route. Upload it in Brightspace, you watch it over there. You see it over there. So watching, you can also watch the video lecture is there as well. But if I would be in your position, I would be at least write minimum amount of thing, maybe like the sketch, right, Joe, and a little bit of the highlights, okay? So you can later connect it with the slide materials. All right. So okay. So what is the problem? The problem here, you're seeing a car, right? The car with a 1500 kilogram weight or mass, okay, generated traction force F that is described by this. So traction force F is like the force that required for the car to move, right? And this traction force initially ramping up from 0 to 6 kilonewton, okay, from 0 to 2 seconds, and then it just steady for 6 kilonewton until 6 seconds. Now this car is not obviously running for 6 seconds, it's running for a while, for so long we don't know, but we are doing the math for this 6 seconds, okay? Again, so the initial ramp up time is 2 seconds, and then 2 to 6 seconds, that another 4 seconds the car is running in a constant speed. So that's the situation. There's the force value, traction force values given for the car. The car mass is given as like 1500 kg. Okay. The speed of the car, you gotta find at this moment at time t equal to 6 seconds. Okay, so basically you gotta find the velocity at this moment. Okay, so let's try to dig through a little bit more about this problem. Okay, so here on this car itself, I'm gonna now delete some of the stuff, so I have like a little bit more stuff here. So I have this thing. Okay, sorry. All right, so I have this thing has a weight w dt. What do you think I write is force multiplied? What is the force? You know that, right? Force multiplied time is the impact. So that's the impact due to the weight of this car, and you know that w is mg. Everybody know that, right? M is the mass and g is the gravity. Okay, so then there's a normal force always act. There's a normal force always act from the ground to the car wheel, and this is anti, and it's the normal force. We have used normal force all the time, right? And the traction force impact can be written as FDT. So these are the things that I wrote here only for impact, right? Now there is the momentum thing as well, like two velocities. At 6 seconds, there is a velocity v that you gotta find, and in initial time, it does have another velocity. You can say like the car starts from zero, right? Because the force traction force is zero. You see that, right? At 0 second. So initially the velocity is zero. At 6 seconds, you got to find the velocity. Do you understand? All right. So that's pretty much it. The car mass is given as 1500 kg. And other than that, you have these three different forces possibly act on the car. Again, what are them? Due to the weight, there is the impact. Due to the normal force, there is an impact. And due to the traction force, there is an impact. There's nothing more, right? Just these three things. All right. So to solve this problem, let's deal with that. The traction force impact, how gonna find that? Let's just focus on that, because we are given with this rectangle and the triangle, like the force increment for the triangle and the steady force rectangle. So from there you should be able to find the value of the impact for the traction force. Again, force multiplied time is the impact, right? So they gave you the force variation, and they gave you how long it is happening. So you have the time, you have the force, you just multiply them. It makes sense for the traction force. So again, for traction force impact can be fine. Let me write it here. Impact. Actually, I should be doing it a little bit of. I'm gonna do it a little later. A little bit of engineering format. So let's start with givens. So what is the givens? The mass of the car is given. You take the class note. 1500 watt. Sorry, 1500 kg. I'm saying what? At time t equal to 0, right? The velocity v is 0. Okay, car starts from the 0, and you gotta find at time, not that much. We can write it as a given. Okay, you gotta find at time t equal to 6 seconds, right? What is the velocity? That's what you're trying to find, right? And then you'd like to do this impact momentum diagram. Always remember that impact momentum diagram. Okay, so the impact momentum diagram can be written this way. So you say like this box here is a car. You can assume anything, right? So this is the car, and this another box is for impact, right? The car is like the impact, that's you're seeing it here. And then you have this mv1 equals 0, because the velocity is 0, right? It's moving in this direction. Okay, the traction is in direction. So you have this weight, what I just draw over there on the car, I'm redoing the same thing here. Normal force impact and the traction force impact, right? And then you have this final velocity is v2 with m2, right? And they call this thing called impact. Let me write it this way: impact and momentum diagram. Okay, You got it? Aline, you're taking the class note? Take the class note. All right, now we are doing the solution. Is it okay if I'm going to do the solution here? I guess it would be more space in that way. Okay, if we're going to start from here. All right, on the solution, okay, two things you can do. You can first start writing the equation first, okay, as an overview. So equation is like an impact and momentum equation. Again, you can write this way. Momentum and impulse diagram is done. Now you can write this principle of impulse and momentum, right? So you can apply principle. That's the way I want you to write in the exam. So principle of impulse and momentum. And after I'm writing the equation, I'm giving you time to catch up with the writing, okay? So on that, you have to write the initial momentum, mv1, okay, plus the summation of forces. So that's always for impact. What you do, you add the summation of forces, right? So impacts are not necessarily like direction, it's direction independent. Does it make sense? So the impact force multiplied the time is the direction independent, okay? So like there are like three forces, right? These normal forces, this weight, and this normal forces, that then this weight, and you have this impulse as well, right? So let's try to find that. So you have this in the right side mv2. Okay, so then you have this 1500 multiplied 0. Now on that spec, like the weight and normal force, since those are on the wheel itself, so you can cancel them out and you only have the traction impact, right? On that impact you have this two zone. I can do it this way. Okay, so for this triangle, right, the impact would be, so I'm dealing with the impact. So triangle, the impact would be, remember, so this is like 6 kilonewton, right? And this is like 2 second. So this is a triangle. You can find the area under the curve. Anybody remember the triangle area? Yes, I'll do exactly same. Half of 2 second, okay, multiplied 6 kilonewton, right? So that's my impact. That's for the first one. And for the second one, okay, so the second one is very straightforward. You see, you do have this 2 second here, 6 second here, and this is still 6 kilonewton, right? And this is a rectangle. For rectangle, impact would be what? The 6 kilonewton. All right, so this 6 kilonewton multiplied by 6 minus 2, like 4 second, right? All right, now that I have the impact, all I'm going to do just plug those impact values to find the velocity, the final velocity, okay? This one is very straightforward problem. Maybe you have a value already. The velocity is 20 meter per second. See if you get that value, okay? The final velocity. If you are not on that position, it's all right. I'm giving you time to catch up to this, whatever happened so far. All right. So, I mean, the rest of the thing here, obviously, I'm going to plug the impact two values here plus each other, and then I'm gonna on the right side write the mv2, where m is known, right, Joe? It's 1500. So the v2 is what you gotta find. Okay. And again, the final result for the velocity is 20. You found it already? Okay, to the man. You want me to write this line as well? Okay. Let me write this line as well. So you do have this half of 2 second multiplied, 6 kilonewton is 6000 newton, right? Everyone know that. You got to convert that, and then plus then 6 minus 2 second, right? multiplied this. This 6,000 is not good. This is 6,000 Newton equal. This M is what? 1500 kg multiplied V2. So you got to find the V2 value, right? See if you can find the V2 value. We're going to do this math further. You're going to have obviously 0 here, right? And then this will be 2 and 2 are going to cancel out. You'll have 6,000 Newton second. Remember, that's the impact unit, Newton second, okay? And then you have this 4 multiplied 6,000 is 24,000, I'm sorry, Newton second. Should be equal to 1500 kg multiplied the velocity, okay? And should be finding the velocity. What is the velocity value found? Anyone? Is it 20? Yep. If you got the 20, then you got the right result, okay? So again, you gotta do 1500 at the denominator, 6,000 plus 24,000, okay? And this is Newton second, this is kg. If you'd like to explore a little bit more about the unit, Newton is what? Newton is what?
Kilogram per meter per second square.
Exactly. So kilogram meter per second square multiplied second. This second square we're going to cancel out. Kg we're going to cancel out this way. So we're going to leave with only what? This is meter per second, right? This is notes. Side note. Nothing to do with the math. Just for understanding purpose only. All right. So again, the result, if you're going to do it, you'll be finding 20 feet per second. 20 meter per second. Let me write the final result. So the velocity would be 20 meter per second. That's your final result. Okay? I do have plenty of time to do the second problem as well. Very straightforward, a single one. Okay. This is an easy problem. That's why I felt like we should be doing 2 problems today. To be frank, not that much left. This is week 11 running. Week 12, you'll have that. Week 11, the next exam. Week 12, 1 class. I won't be here, right? Because I really don't have that much, so I'm not gonna do a video lecture. Okay, there's no need. All right, so I'll have Monday and Friday class. Okay, so on Monday and Friday, I should be able to almost finish this chapter by week 12, right? And then there's 2 more weeks left. So I have another chapter with just 2 problems. I can barely introduce that. Okay, this is chapter 15. We're doing chapter 16 that I'm talking. Okay. That's the plan for the rest of the semester. I usually don't do any project, but if anyone would like to do any project, let me know. I'll try to help you. Okay, on this one. On this class, since I started teaching quite some time now, I'm gonna start doing project again. This if you'd like to do something, just let me know. Project means something hands-on. Okay, if you'd like to test any of the math that you're doing with anything, right? If you're interested, we'll work together. All right. Other than that, let me know. Does anyone have any questions? So again, to give you an overview of the whole thing, what is happening here? The car does have a traction force, and the traction force, the force and time history was given, right? So it has initial ramp up 0 to 2 seconds, 0 to 6 kilometer, and then 6 kilometer continuous up. I don't know up to when. It has up here. They said explore it up to 6 seconds, and then you had this principle of impulse and momentum equation where you have the change of momentum is equal to impact, basically. Okay. So change of momentum, we have to only find the v2 or find a velocity, right? Where the v1 was 0, it starts from initial time 0, right? So the velocity was 0 as well. And then you have this impact, which was force multiplied distance. You found it from the time history of the force, of traction force. And then you finally get the final velocity 20 meters per second. Okay, and the final thing is there is a side note. There is a side note here. Okay, how this Newton second become, meter per second kg. Okay, so that's something to explore. Other than that, there's not that much to talk. Any question? Everyone understand? Did you know you got it? Arlene? Okay. Take the class note, okay? Writing is helpful. I do have another problem. Let's solve it. All right, so in this case here, let me start reading the problem. So I have a 20 kilogram crate is moving downward this way. This is the crate. That's it. Do you see that? So this B is the crate. Crate means like some load, right? That is moved by what? You see there is a motor here. Motor is moving. There's a pulley arrangement, right? Moving means it's going up, right? Sorry, it's going down. I'm sorry, it's going down at a velocity of 10 meters per second, right? See that? All right, so this force here, this is the force exerted by the motor. So motor M, this is the M motor, right? Okay, this force here that we're seeing, it got increased from 0 to 6 seconds, right? Sorry. So 0 to 6 seconds, from 150 to 450. So this is 450. What? Newton. So this motor needs to exert this amount of force steadily up. So so the crate can move downward, right? The crate is moving downward. All right. So the crate is moving downward. The crate is moving downward. The motor pulls on the cable with the force F, which has a magnitude that varies as shown in the graph. Okay. The speed of the crate. So at 6 seconds, the speed of the crate you gotta find. So the initial velocity, okay, initial velocity was given as 10 meters per second for the crate, and then the motor comes in action. It does have a force varying from what is the force initially? 150, right? 150 Newton to 450 Newton. All right. Again, the motor is pulling the crate up. We understand this, right? Crate is initially moving down to a velocity of negative 10. All right. The crate weight is given as well, not directly. The mass is given 40. You just have to find the weight by multiplying G. 40 kilogram, right? All right. So to find the speed at 6 seconds. Now again, initially when the motor is not in action, the crate is coming down. You understand it, Arlene, right? The crate is coming down, nothing to hold, right? 10 meters per second, and then motor is start to run, will try to pull up, okay, and the velocity now is no longer going down, it's going up, right? So when the velocity is going up, what is happening? The final velocity is what? The final velocity will be no longer negative, right? Because the motor is pulling up, the crate is going up, and I have the result 138 meters per second. It's huge velocity, okay? Do you understand the problem? All right. If you understand the problem, the first thing that you'd be doing always, engineering format, givens. Start with the givens. And I think I upload another homework, okay, related with this in Brightspace. That is homework number 10 or 9? 9. I have 2 more homeworks, right? So I may upload one. I don't know. I mean, this is only week 11, right? So there is no project. There is the take-home finals. So something that will keep you busy. Not that many problems there. I'll talk with the solution manual as well, like with the hints and everything. So M, for sure you will have another homework. So 40 kg, maybe 2. And then the G is 9.81 meter per second square. The velocity minus 10 meter per second. Now you understand why did I write negative? Because initially the crate is moving down, right? That's what they said, downward. Okay, so this is X and Y. If you're gonna say this is X, this is Y. So that's the reason. Like this negative Y is minus 10 meter per second. All right. So then you gotta find. Let me do the find here. You gotta find what? The V2, the final velocity at time t equal to 6 seconds. Okay. Okay, the solution. So now, first thing first, you would be doing the impulse and momentum diagram. You would like to draw that. So impulse and what is the impulse and momentum diagram? So now you have this crate here, right? Initially is moving down, MB1, and then you had the impact happen due to two force, right? One force is, take a look here, what is happening? You have this pulley here, right? So this pulley is going up because the crate is moving up, right? So that's why you have this force twice, right, on these two different ropes. So you can see the reason, I don't know if you remember that. So see, this is the motor, right? So the motor does have like this force F, right? And there's this pulley. See if you understand. This F is here, right? And then this comes here. So there's the F here, right? Christian, you understand? This is the thing we explored before, right? So there's this F here. So there needs to be another F, right? From statics class, we know that, right? So that's the reason we have this 2F in the crate. How many F's you have? Like how many forces you have? Like see, if the motor pull it up at F force, this crate will gonna experience 2 times F because of this, right? You guys are familiar with this gear theory, machine design, right? You guys are familiar with that, right? Small gear, how it gets transferred to the big gear, right? So that it is like that. Okay, think this way. Okay, even if the motor is pulling up with a force, but the crate you can experience twice the force. Okay. Now energy wise, that's a different concept. Energy is always same. You know that, right? There is not like suddenly additional energy pop up for this thing to be twice the force, right? That is a different concept. But force definitely follows this principle from the force principle, Newton's second law. Okay. All right. So then you have this MB1, so M1, B1, and then you have this obviously the weight. Do you have a normal force here? I don't think so. Because it's hanging out there somewhere. So we don't care about that normal force. And then we have this, obviously, this impact for this force, right, Joe? And then the weight, you can ignore that. Is this weight as well? Should be equal to MB2. Now this MB2 is moving up, obviously, because the motor has to do something, and it might will gonna move it up, right? Because it does any other way. All right. So then, if you understand this, by the way, you can possibly put y and x direction, right, to understand it better. And then you can do this thing here, principle, just the way you did, principle of impulse and momentum. Okay, and on that you have this mv1 plus summation of force from time, summation of force with time dt to find the impact from time t1 to t2, which is 0 to 6 seconds, by the way, right? And then it should be equal mv2. That's the final momentum, right? Okay, so here's the thing. On the left side, you have this negative velocity because initially the crate is moving down. So the m, 40. In the right side, you have this m40. Again, v2 you are trying to find. And the impact forces, right, that we have done it here. on the sketch or impulse momentum diagram, you got to find first. Okay, you can do it here, or I can explain it even further, because they gave you the force time diagram, right? And they said like the force varies from 150 to 450. So it does follows a straight line upward trend. Now to find that area under that curve, you can do integration, or you know how to find the area under this curve, right? If you're gonna just simply make an average of these two forces at initial and final, right? See what I'm saying? Again, what is our goal? To find the impact. Okay, and we know impact is equal what? Force multiplied time. So I have this 450 here, 150 Newton, and this is 0 second, this is 6 second, this is time, and this is force. Okay, to find the impact for this, impact due to the impact, so impact due to force exerted by motor on crate. I would like to write the whole thing so you'll understand it later, because I'm going to write 2F, 2 times the force, right? I was explaining that before. So you'll be writing that. So 2 times F dt. Okay. So this 2 times F dt is what? 2 times 6 multiplied by half of 150 plus 450. And this one is a little difficult to understand if you don't have that much of geometry knowledge, but I'll explain it shortly. Just wait for it. So Newton second. All right. See, you guys remember a trapezoid area? Does it look like a trapezoid? Everybody knows trapezoid, right? That's something you must learn it in calculus, if not geometry class. If you didn't take geometry, for sure you'll learn it in calculus, right? So trapezoid here is like 150 and 450 is the half of that, right? Multiplied the x-axis value, which is in second, by the way, 0 to 6 second. So you have 6. Okay. Did you understand? You remember the trapezoid area? So that's the average of these two high points in y-axis, 150 and 450. And so you add them up, divided by 2, that's the average, right? Okay, multiplied by the 6 in x-axis. Everyone understand this? You got it? So the trapezoid area. All right, so if you understand that, just simply plug the values and get a value. Like here, you'd be getting 3600. Now everybody knows this, right? To find the integration, there's another easiest way would be area under the curve. You guys remember that from calculus, right? Integration is area under the curve. This is exactly what we're doing. Instead of doing the integration, because I don't have an equation for f directly, it is indirectly. You can find the straight line equation and do the same thing, but it doesn't make any sense. It's like very straightforward. You can find it this way. All right, if you find that, and then there's this another impact due to the weight, right? So let's find that. So impact due to the weight. What is that impact? So you have this W dt, and W means mg, right? We don't know that. And then mg, is the m and g both are constant, or those values are varying? Those are constant, right? So I should be able to take it out from the integration, right? Right, Joe? Any constant should be out from the integration, right? There's no place for constant inside the integration. So I have this dt and 0 to 6 second. Agree? So 0 second to 6 second. You would agree on this? Now, if this 6 second is confusing you, I mean, I can take out this s, right? Make your life more simpler. 0 to 6. It's the same thing I'm writing, right? Instead of the unit. Okay, then you'd like to plug the values, right? What would be the value? So you have this mg and this 6 minus 0, right? This is in second. You now must need to put the unit, because you didn't quite put anything for mg unit yet. So g is 9.81 meter per second square. and multiplied 6 seconds, right? And if you're going to do the math, you're going to come the value in Newton second, which would be 2354 Newton second. Okay, now that we have these two impacts, now we can start to plug all the values, right? See, I did talk about it. Like if you have an impact, right, that impact is not sign dependent, right? It doesn't matter plus or minus, right? It's going up or down. Impact happened. So in a minimum amount of time. So you would be doing it like you start to plug all the values here. So you have in this equation here, so this m v1 plus, I'll be writing that w dt plus 0 to 6 2 times the f dt. You can write the 2 here, that would be more clear, m v2, and then you can start to plug the values. So what is the value of m? 40 kg. What is the value of the velocity? -10. I'm writing them. Plus, I do have those two things calculated. So one is 2354 Newton second plus another one is 3600 Newton second. And I have again 40 kg here, right? And then I have this V2 that I'm trying to find. So then all you got to do, just do the math, rearrange things, right? So you're going to have 2354 plus 3600 minus 400. So whole thing can be written as Newton second, right? It's the same thing. And then you can divide it by 40 kg. Okay. And we've seen before how this Newton second become meter per second. So you're going to have a value of, what is the V2 value found? 138.85. That's your final result. Almost used the whole class time today. That's it. All right, so there's some impacts problem. It should be enough for you to deal with the homework that you want to upload it. The old one is due today. I've seen just one student submit it so far. Okay, I'm not expecting him. It's due today, right? Or 8 or 10. I forgot. 10? The 9? 9?
It's due Friday.
The whole week. Still, submit it by Friday. And then the new one will be due next week, end of next week, I believe, on the Friday. So back, if those who were done, almost done, you can start solving the new homework, right? If you have time interested. And other than that, I would say like focus on the exam. Okay, the question that I have is very similar to the one that I solved here. You don't miss the class watch the video that you see, I did talk about that, right? That's a very, very difficult problem, okay? So, try to do it at least one time before coming to class. I can tell you one thing, the integration will be completely different. Okay, the equation y equal to x squared, half of x squared, you'll be seeing that equation. You'll be seeing a different equation, okay? So just bear it in mind. So you gotta deal with that integration or derivative. Not the integration, you gotta do the derivative, right? 2 times the derivative. So bear it in mind. You do a review of the derivative before coming to the exam, okay? That should help you. Other than that, I don't have that much. It's just the summary is the same thing like the first problem, okay? The principle of impact and impulse. I'm gonna